Hey
everyone, for our capstone project, we decided to pick a topic that is not well understood or studied by many, which is what are the predictors of a good work-life balance for men? In this project, we deployed statistical and machine learning methods to identify factors which contribute to a better work-life balance. Why? Because we want to identify factors that contribute to a healthy living and also to support growing research in the field of men's health. As currently we ourselves are trying to manage our demanding jobs and the challenging yet rewarding master's program, this opportunity to study the factors that contribute to a better life couldn't have come at a better time. The dataset was collected by Authentic Happiness, a website developed by Positive Psychology Center at the University of Pennsylvania. This data was collected between 2015 and 2020, included both male and female respondents. However, for our analysis purposes, we focus solely on the male counterparts. As you can see in the snapshot, the dataset contained variables or questions for respondents asking about the number of steps taken in a day or to how much a sense of accomplishment someone feels. Also want to quickly talk about our response variable, which is our work-life balance score or the WLB score. Many factors contribute to the WLB score, which my friend Jack will discuss shortly. Our belief based on our findings reveal that a higher WLB score leads to a healthier lifestyle. To clean up our data and get it ready for model consumption, we performed the standard EDA practices, such as removing missing values, metadata columns, identifying outliers through box plots and histograms, and keeping our focus on numeric columns for our selected model. Now I will hand it over to Jack to talk about our approach to model selection and our findings as a result.
Yeah, so as mentioned before, our data set included a work-life balance score for each entry, and our goal was to figure out how to best predict that score, as well as identify different variables involved, most importantly, in the prediction of that score. And what we chose to employ was a random forest predictive model, primarily because of the reduction of overfitting and the ability of the forest to identify variables with the highest influence. In order to construct this model, we performed a bootstrapping method where our test set, 1/3 the size of our original set, was created by random selection of data entry with replacement. And what we did with that training set was create or generate our random forest model and tested it on the test set that we created through bootstrapping. Through our model of 100 different decision trees, we were able to have a mean squared error of 158.31, which was a value we were really proud of as a measure of average squared difference between the actual and predicted work-life balance score. And the work-life balance score itself has a range between 400 and 800. So being within 100 to 200 points of that was something we felt confident about. Similarly, our R squared value was 0.93, meaning that 93% of the variance in work-life balance could be explained by our model. And with that, we felt that we could move forward with our model in identifying variables of high influence. From our random forest, we were able to identify achievement, tasks completed, supporting others, places visited, and sufficient income as variables that were most important in predicting a high work-life balance score. On the right-hand side, you can see each importance value associated with those variables as well. And included on the bottom right, we are including a snapshot of our random forest where you can see at each decision tree, a variable is taken into consideration, and the tree favors the path at which that squared error is going to be the lowest, leading us to an overall predicted score. In To garner a second perspective on our data, we also wanted to run a correlation matrix between all variables and the work-life balance score to make sure that our variables we had identified were also going to rank of high importance through this method as well. And what we found was that supporting others' task completion and achievement specifically did have some of the highest correlation when plotted against work-life balance score, giving us another layer of confidence as we moved forward with our work. And of the variables that were not included in the correlation matrix to have high correlation that were identified by our random forest, we set aside as potential variables to explore in further analysis or future directions for our project, as we still believe that they do have a large correlation to our work-life balance score. So to gain insight on the variables identified, we ran some descriptive statistics on each one, creating a box plot for each. So as you can see, example being achievement, if you had a target work-life balance score, or if you were taking a look at someone who was ranking low on achievement that was looking to improve their work-life balance score, you can see just where the sample participants were reporting their different achievement levels compared to their score. So those who were achieving more, scoring 8, 9, or 10 on the achievement scale, were kind of predicted or calculated to have a higher work-life balance score. Similarly, with supporting others, those who were being most supportive, either at work, at home, in their social lives, were having higher work-life balance scores. And when you take a look at the different description of the variables on the left, we're summarizing our findings with higher achievement levels correlate to better work-life balance scores, supporting others, higher work-life balance scores. The faster you get your to-do list completed, the faster you take care of priority tasks, the more work-life balance you're going to have. And more importantly, too, places visited, people who travel have higher work-life balance scores. So from our findings, we're creating a comprehensive map of how people from different workplace, different social settings can overall improve their work-life balance scores. And behind those plots, we have also calculated the mean, the standard deviation, and the different interquartile ranges for each, giving us statistic insights to just where we can plot ourselves and where we can plot others who are looking to improve their lives. So in conclusion, taking all of our findings into consideration, one of the most important findings was that life beyond work is important. So personal goals, social connections, and just different ways that you can explore work-life balance, emphasizing that what we do outside of the office does matter and has a large influence on how we perform. Taking machine learning driven insights into consideration here, through our random forest, we were able to capture different complex patterns, kind of engaging with robust and reliable insights to lead us to these findings and providing with comprehensive predictors for work-life balance. Similarly, next-gen models, just getting to experiment with different algorithms was also really important here as we were able to kind of prove and disprove which variables were most important. And kind of circling back to our overall goal, having a big future impact on advancing the topic of men's health and different ways that we can apply ethics statistics and ethical AI in that conversation is very important. Here we have a summary of our collaboration on this project, and we thank you for taking a look at our work and watching our video.
Thank you.